Tests for Group 2 lead ions. Lead is a soft grey metal. It is used in shots and weights. Lead is found in many salts like lead chloride and lead sulfate as lead-2 ions. In Group 2, lead-2 ions are precipitated as their sulfides by passing hydrogen sulfide gas through their solution. Our aim here is to test for the presence of Group 2 lead ions in a given salt. First, we look at the preliminary tests of lead ions. Dry heating test. Materials required: original salt, test tube holder and Bunsen burner. Procedure: take a small quantity of salt in a test tube. Heat it over the Bunsen burner. The salt becomes brown when hot and yellow when cold, indicating the presence of lead ions. Charcoal cavity test. Materials required: mixture of salt and sodium carbonate, charcoal piece, distilled water, dropper, tongs, blowpipe and Bunsen burner. Procedure: take a mixture of a small quantity of salt and double its quantity of sodium carbonate in a watch glass. Take a charcoal piece with small cavity in it. Using a spatula, take a small quantity of the mixture and place it in the cavity of the charcoal piece. Using a dropper, add a few drops of distilled water to the mixture to moisten it. Hold the charcoal piece in front of the reducing flame of the Bunsen burner using tongs. Now, direct the reducing flame of the Bunsen burner on the cavity by means of a mouth blow pipe and heat strongly for some time. A brown residue is obtained on heating and it becomes yellow on cooling, indicating the presence of lead-2 ions. Flame test. Materials required: original salt, concentrated hydrochloric acid, dropper, glass rod, platinum wire loop and Bunsen burner. Procedure: take a small quantity of salt in a watch glass. To this, add a few drops of concentrated hydrochloric acid using a dropper. Mix the contents of the watch glass using a glass rod to make a paste. Take a small amount of the paste on the platinum wire loop and introduce it into the oxidizing flame of the Bunsen burner. Dull bluish white flame indicates the presence of lead-2 ions. Next, we look at the analysis of lead-2 ions present in Group 2. Materials required: salt solution in a test tube, dilute hydrochloric acid, hydrogen sulfide gas, 50% nitric acid, dilute sulfuric acid, alcohol, droppers, centrifuge tube and water bath. Procedure: take a small quantity of dilute hydrochloric acid using a dropper. Add it into the test tube containing a small volume of salt solution. Now, pass hydrogen sulfide gas through the solution. Lead-2 ions present in the salt solution react with hydrogen sulfide to form black precipitate of lead sulfide. Transfer the precipitate into a centrifuge tube to separate it by centrifugation. To the centrifuged and washed precipitate, add a small quantity of 50% nitric acid using a dropper. Heat the contents of the test tube in a water bath. Lead sulfide reacts with nitric acid to form soluble lead nitrate. Now, using a dropper, add a small quantity of dilute sulfuric acid to the test tube. Then add a small quantity of alcohol using another dropper. Soluble lead nitrate reacts with sulfuric acid and alcohol to form white precipitate of lead sulfate. Potassium iodide test. Materials required: precipitate obtained in the group analysis, potassium iodide solution, hot ammonium acetate and dropper. Procedure: take 1 part of the precipitate obtained in the group analysis in a test tube. To this, add a small quantity of hot ammonium acetate solution using a dropper. Shake the test tube well. The precipitate dissolves in ammonium acetate due to the formation of lead acetate by the reaction of lead sulfate with ammonium acetate. Now, add a small quantity of potassium iodide solution to the test tube. Lead acetate reacts with potassium iodide to form a yellow precipitate of lead iodide. Potassium chromate test. Materials required: the solution obtained in the group analysis, potassium chromate, test tube and dropper. Procedure: take 1 part of the precipitate obtained in the group analysis in a test tube. To this, add a small quantity of hot ammonium acetate solution using a dropper. Shake the test tube well. The precipitate dissolves in ammonium acetate due to the formation of lead acetate by the reaction of lead sulfate with ammonium acetate. To this, add a small quantity of potassium chromate solution using a dropper. Lead acetate reacts with potassium chromate to form a yellow precipitate of lead chromate. Precautions: handle mineral acids with proper care because they are highly hazardous. Heating should be done very carefully.